Hello friends. So today we are going to study three very interesting topics. So one is PIR sensor, then we have photoresistors, and then we have potentiometers. The variable potentiometer is actually the variable resistance value. So that we are going to study in today's experiment. So let us start with PIR sensor. So PIR sensor is actually passive infrared sensor. So you know about infrared sensors means like in TV remotes and all, infrared is there. So it's to control different channels. Now, what is passive infrared? Passive infrared means it doesn't emit infrared. It actually depends on receiving the infrared. So what happens when any human body or like this structure, if any human body or if any animal body or anything that is live, so those things or any other object also that emits heat, so that changes actually the value of infrared coming to this type of dome. In our sensors, this type of dome structure is there. So what it does, so whenever any amount of heating effect is coming from the human body or any animal body, so that time what will happen, no, it will get activated, it will receive and it will get activated. So that sensor we are going to study in today's class. So physical PIR sensor looks like this. In your college washrooms or in multiple, in different lab rooms, you can see that this type of sensors are actually installed. So these type of sensors are actually used to identify that whether some motion is there, some human being is there, and at that time only it saves the electricity and it controls the devices. So if you remove this type of cup, that is this dome, it will look like this. So what happens? What for this dome is there? This dome is to collect the, like if any type of infrared is coming, it should always hit in the same spot, to the sensor spot. So this is a pyroelectric type of sensor. Pyroelectric is nothing but that type of sensor that gets activated due to infrared. So this dome is there, and if you remove this one, it will look like this. If you turn this one in the back side, the sensor will look like this one. So in that, you see that these are two potentiometers, two variable resistors. The same we are going to study today also. So these potentiometer, how they work, if you rotate this one, it will increase the output timing. The timing of the sensors will be, I mean, if you are moving your hand, the response time will increase and decrease based on this potentiometer. This will increase the sensitivity, like increase and decrease the sensitivity. Sensitivity in the sense like it should activate from this distance, or it should activate from this distance, or it should activate from this distance. The range in that sense, and the movement sensitivity will control from this one. Others are also important. You can give here 5 to 20 volts, and this is the output signal, and this is the ground. So these things we have to consider. Those we are going to study. So introduction. So what is PIR sensor? So that I already told you, a PIR is a passive infrared sensor that actually gets activated when it's finding that any temperature variance is there. Temperature variation is there means it will get activated. So this is the working principle that I have already explained you. Then application of PIR sensor. So application of PIR sensor is it is used in security systems to identify the presence of somebody. Then automatic lighting systems in as in your washrooms of the institutions or in industries or in companies. This is installed to identify if somebody is in the washroom, then that will activate the lights. Then in home automation also we used. If somebody is in the room, that time only the lights and fans will get activated. Energy conservations to save the electricity that we use, and that is actually our take-home assignment also. Then outdoor lighting. So outdoor lighting in the sense like if somebody is moving out of your house also, then you can control it. Then in robotics also, basically to identify the presence of some live objects, we are actually using that one. Art installation means like suppose somebody comes to any art gallery and they are standing in front of some painting, that time only the lights would get on. So for that also we use this one. So in healthcare also that we want to track some patient, like the patient is moving or not, or patient is moving in that area where they should not be moving, or enough movement is not there. For those things also we use PIR sensors. Yes, coming to the practical session. So what we are going to do, we are going to take one Arduino, and you know how to take it. Then we are going to take a PIR sensor, type PIR. So in market there are two types of PIR sensors basically available. One is in that 3-pin, and some are actually available that is having 4-pin also. So you can see that here one signal is there, one power is there, and one ground is there. In some sensors there will be digital output and analog output. So analog output means if more amount of, if somebody is moving nearby, that time the voltage will be coming, will be more. If somebody is will be less, and if somebody is moving very far off, then the analog voltage will be less. But in this type of digital type sensors, what will happen? That only one output will be there. If somebody is moving, one digital output, one. If somebody is not moving, then zero. That is the only condition. So that is the basic setup that we are going to see now. So for that, you know that here is one signal, here is power, and here is ground. So what we'll do, we'll connect this signal with pin number 2. As we have to identify whether it's on or off. So for on-off condition, we don't need PWM. We just need a basic input and output. So for that, I have connected this one to pin number 2. Then we have power. Power will connect in 5 volts. We'll connect in 5 volts. And you know that we have to connect in red color. And this is ground. So this ground, you can connect it here. You can give like this also, it won't short circuit. Overlapping wires doesn't short circuit in Tinkercad. Then this should be black color. Now coming to the code part. So in the coding part, you can see that here we have to first declare that which pin is the input pin. We have declared pin number 2 as the input pin. Now word setup, you know that word setup part of the code runs only once. So we have declared that we are going to use serial monitor. So serial monitor means we want to see the output in serial plot also. So for that case, we have to declare what is the baud rate. So the data transmission rate is 9600. So we are using this baud rate as 9600. Now name of the PIR pin is, pin number 2 will be the input pin. Because why input pin? Because we are giving, the sensor is giving the input to the Arduino. So this will be input pin. So we have declared this as input pin. Now in the loop part, digital read PIR pin. So you remember this is a digital pin. These are the digital pins. And these are the analog pins. So we have connected the output in, input in digital pins. So we are going to write like this. So we have to write like digital read. We are not using analog read. This time we are using digital read. So digital read, which one? We are reading pin number 2. What is the name of the pin number 2? Pin number 2's name is PIR pin. So whatever values are coming from this one, generally 1 and 0 only will be coming there. So that we have to store in this int value. And that we are going to plot. So it will plot that whatever the value is coming, that will simply plot it here. Now let's run the simulation and see that what output is coming. So start the simulation. And now you see, if I click here, it will show you the range of the PIR. So this is the range of the PIR. If I start moving, see, somebody starts moving, the PIR sensor value is 1 in the range. If somebody goes out of the range, see, it's coming 0. And somebody is inside the range also. But if they are idle, they are not moving, then PIR is not getting any infrared variations. So when they are not getting any infrared variations, in that case, what will happen? It won't be getting any signal. So it will be 0. So the person is moving like this. So once you entered in the workflow, we have to give our Arduino will identify. Okay, sensor will identify, and in Arduino we have to give the command that if the movement is not there, still we have to be oning the light for maybe for 30 minutes, 40 minutes, 70 minutes, whatever we want. So after 30 minutes, it will again off the light. If somebody is moving again, it will again activate. So that is the logic given there. So same logic we are going to use in our take-home assignment. So you can see, so this is the part, and you should be you should understand this one. In this we have used digital input, not analog input. Analog input also will teach you in the next experiment where we are going to use potentiometer. So in the same code, what I did, I did a small change. One small change is that what I did is I added one buzzer here. I added a buzzer. I have just connected positive of this buzzer to pin number 4 and negative of this buzzer to ground. You can just search buzzer and you'll get it. Simply I have connected positive to pin number 4 and negative to pin number, this ground. Then in the code part also I have declared one buzzer. So I have connected the buzzer pin number 4. So that I have declared here. And we know that buzzer pin is pin number 4. So I should declare here output, but like this also it goes. It will work like this also, but straight away you have to give output. Then in the void loop, what I did, I just gave one if else statement. So if PIR value is equal to 1, it means that whatever is coming here, if it is on, in that condition, what it has to do, it has to just print motion detected. If it is finding that otherwise, it has to print ideal. So you can write here high also. Here, if you want, you can write high, or sorry, in capital, or you can write 1. 1 means it's on. So if PIR sensor is giving a high value or 1 value means okay, motion is detected. If it is not giving any value means it's idle. That's all. So by this way, actually we want to just add one buzzer, and I want to run. So but now the buzzer will not make any sound because we have not declared it to get on or off. Just we have given it to add a serial monitor. Now we'll see the output in serial monitor. So we'll go to code and we'll go to serial monitor. Now you see, if I put anything here, I mean if any motion is detected, now you see it will come. Motion detected. Motion detected, motion detected will come. If I am not moving anything, it will come idle, idle, idle. So now here what we'll do? We'll just simply write digital write. Digital write. And what was the name of the pin? Buzzer. BUZZ, buzzer, and we have to give high. Otherwise, what will happen? Instead of giving this one, you can give here. This should be in the low condition. And now we'll start the simulation. Okay, it's giving that there is a wrong. Okay. This will just make the sound here. Actually, that D I gave, no, this should be small letter. If you move this one, it will make the sound. You can give here you can give here some delay also, like that it should be keep on running for 20 minutes, 30 minutes, 50 minutes. After that again it will become idle. Then again if the movement is coming, then again it should activate. So those things are up to you that you can keep on giving here. Thank you. So this experiment is about potentiometer. So this is a potentiometer. Potentiometer is nothing but it's a variable resistor. Means whatever values you want to, I mean resistance, whatever value you want, you can take it from here. So you can see that this is a 10 kilo ohm resistor. You can change it to any ohm value like that. So this 10 kilo ohm means from 0 ohm to 10 kilo ohm, it can give you the value. You have just to move this one and you will be able to see the resistance value keep on increasing. So before this we have used this type of resistor that have a constant value. But this type of variable resistor, you can change the value as per your requirement. If you are setting this to ohm, 0 to 10 ohm it will be going. But here it is 10 kilo ohm. So from 0 to 10 kilo ohm, you can give any value, whatever you want. So that is the logic. So what I have done here, you can see here, if you go to this part, this is terminal 1, this is terminal 2, and this is wiper. So terminal 1 and terminal 2 are the inputs and wiper is always the output. Now, in the first terminal, if you connect the ground, and in the last terminal, I mean second terminal, if you connect the positive, what will happen? If you increase the value, the resistance value increases. When you decrease this value, the resistance value decreases. But if you connect this ground here and this positive in the first terminal, what will happen? I mean to say this black into red and red into black. In that condition, what will happen? When you increase this value, what will happen? The resistance value will decrease in that case. In this setup, what I have used right now, resistance value increases. In that case, the resistance value decreases. So that only happens here, nothing else. Now this is output. So this output of this potentiometer we are giving to the analog of Arduino to measure that what value is actually coming from here. So it will allow some amount of current to pass this one, and this current will be controlled by this potentiometer. So that we are going to do, and whatever value this microcontroller is getting, that it will analyze, and after analyzing it will give this certain amount of current to this LED to glow. So here we use mapping. Mapping means here the values whatever we are plotting, that will go from 0 to 1023, 0 to 1023. Okay, so that value will be mapped from 0 to 255, because you know that 255 means maximum 5-volt value and 0 means 0-volt value. So that input value should be mapped with the output value. So that we are going to do in this code. So where we have connected the potentiometer, we have connected the potentiometer to analog pin 0. So that is actually available here. You see that I have connected the potentiometer to. See, you should never count this one because these are positive voltage and ground. So that should not be counted. Always input is counted here. So that we are going to write in the code. So input is coming from analog pin. Analog pins are mostly input pins only. So we don't need to declare what is input, what is output here. Now LED pin is a digital pin, and that we have connected in pin number 9, because you remember that when we taught you PWM, we told you that we are going to use always this wave type of structures, because wave pins are only the PWM pins. So that's why we are going to use pin number 9. You can use 10 also, 11 also, 6, 5, 3, anything you use. So in the setup program, as usual, we are going to declare that LED pin number 9 is the output pin. Then we are giving the baud rate. And here, analog read means we are not using digital read this time. This experiment is about analog read. So we are going to read the pot value, potentiometer value, and we are going to read the value and store it in the int. Now, potentiometer value, whatever value is coming, that we are going to map. So 0 to 1023. So 0 to 1023, how it will come? It will come from here. By rotating this one, it will come. So whatever value is coming, that it is going to map in the value of 0 to 255. So 0 to 255 will be mapped in here. The maximum 1023 means 255. 0 value means 0. Maybe for example here 512 value is coming, that will be coming here maybe 120 like that. 125 maybe. Now whatever the values it is going to show potentiometer value, and it's going to print the pot value, then PWM value, and it's going to print the PWM value. So this is the pot value and this is the PWM value. We are going to give the PWM accordingly. Then it will write the same thing, whatever it is getting. I mean, this value we are getting, that we are going to write straight away to PWM value, to which one? To LED pin. LED pin is there, this one. So how much value is coming? Based on that, the LED will be keep on glowing. So that we have to check. So now what we'll do? We'll just increase this one. When I told you, when I increase this resistance value, what will happen? The LED is actually not glowing that much because it's allowing very less amount of current to pass through this one. But now when I'm reducing this one, means the resistance value decreases, there it will allow more amount of current to pass and it will glow. Now see in the serial monitor also what is actually happening. So you see that 1023 and 255 value is there. So now what we'll do, we'll just increase this one. When I increase this value, what happens? Potentiometer value is, because as resistance increases, it's allowing very less amount of current to pass. So when the less amount of current is passing, then PWM value also decreases. Now you see here, the same thing happens. What I told you before, that when if we change this positive to negative and negative to positive, what will happen? By increasing this one, we are not going to increase the resistance. By increasing this one, we are going to decrease the resistance. Then that this will be different logic. But this is the correct way to actually connect this one. So by this is our experiment number 2. Thank you. So this is our experiment number 3, where we are going to use LDR. LDR is light dependent resistors. Light dependent resistors are nothing but that type of resistors that change their value based on the light falling on that one. So like you can see this one, these are actually used in for example, automatic lighting systems. So for example, in the street lights, you can see that when the light falls at the daytime, that time the street lights automatically gets off, and night time when the light is not falling on that one, that time the lights turn on. So that type of setups, no, this type of LDRs are actually used. This is also called as photoresistors. So that type of resistors that gets activated by the light. Photo means light there. So that's the meaning. And you can see that I have done what I have done a connection here. I have connected 1 kilo ohm of resistor, and there is a photoresistor. So you can just type here resistor also, it will come. Now that I have connected here in the same setup, this is nothing but the variable resistor what you saw pot. The same structure is I have connected this one. One positive is there, one ground is there, except here one resistor I have given, and one input analog input I have given. So with this actually I just want to map whatever I was mapping before in the potentiometer. The same thing I want to map in the LDR. Now this is LED that will be glowing accordingly, and the code is same. I have not done any change in the code. So the code is exactly same, and just that design I have changed. So that will be easy for you. Now start this code and see. So once I start the simulation and I try to increase the light. So once you increase the light accordingly, you can see that that one, this thing is actually that light of that is increasing. Same way you can see here. If I click here, it will just increase. It will decrease here accordingly. So in the take home assignment, what you have to do, you have to take this one, like in washrooms and all, we have this PIR setup. And whenever if somebody enters, that time it gets activated, and it remains activated for 30 minutes, and after that it gets off. So same way you have to make it on for 30 seconds, and after 30 seconds it should get off. So like that you have to connect some LEDs, some buzzers, some motors, and that those should get on for 30 seconds, and after that it should get off. That is your assignment using PIR sensor. Thank you.